Hello, class. So on this video, we'll continue on to chapter 4. We were working on example 4, where specifically, let me make this bigger. Okay. So specifically, we're looking at how to find the general solution to a non-homogeneous ODE using the method of variation of parameters. And so we went, right, and we saw we have to determine, first find the complementary solution, which we did. Right? And that's all in the notes, in your notes or in the previous video. And then we determine, or we write out these Wronskians, right, which are determinants of particular matrices, which in this case, they're 3 by 3. And in general, if you have an nth order ODE, they're going to be n by n matrices. Right? So we could do it by hand, but instead I'm going to show you how to do it in mathematics. Right? So first, if you remember, the functions that appeared in our Wronskians were cosine, sine, and tangent, and the constant function 1, but you don't have to write that out. Now, here, let me show you how to write out functions. So basically, what you do is, and there's a video under modules called Mathematica Help. Right? I think one of the modules is called Mathematica, and there's one video there called Mathematica Help, where I explain all this. By basically, how do you define a function? Okay, so you write the variable. So already have f1, f2, f3. So let me define a new one, f4. Now, the thing to remember with Mathematica, it's different compared to other programming languages or other computational languages, is that instead of using parentheses, we use brackets. And not only that, I did something wrong here already. Okay, so I'll have to fix this. Well, let's do it here. So you want to write a function of a variable. When you're defining a function for the first time, you want to do the variable and do an underscore. Then, since it's a definition, it's the first time we're writing the function out. Instead of just writing is equal to, you have to write colon equals. And then you write the function, right? X squared plus 3, etc. And then you do shift enter, like usual. So let me do shift enter on each of these ones, right, to run it. And then I'm going to get rid of this. So how do you get rid of a line of code if you want? You just go to these boxes on the right. You can see that each of these boxes correspond to a particular input line. So how do you get rid of something? You click on that line or that vertical line and you click delete. Now, you don't have to put colons at the end of an expression. All this does is suppress the output. Okay, so if I wanted to do, for example, compute what f of 1 is, it gives us this. If I don't want to show that output, I just do f of 1, semicolon, and it'll suppress the output. And then notice that when I define the function, I need to do variable underscore and colon equals. But once I've done that, I can just work with the function as usual, right? So just if you notice here, just did f of 1, right, to evaluate. So then it works out really nicely afterwards. Okay. Now, we need to determine matrices because we're trying to find the determinant of matrices. So how do you define a matrix? Again, give it a variable name. And then you use curly brackets. So what do these curly brackets mean? So each of these curly brackets is a row of your matrix. So if we went back to what the matrices were in our case, so I think the first row, let me remember what they were. So it was 0, 0, 1, cosine, negative cosine, and then sine, cosine, negative cosine, negative sine. Okay. So the first row, just for the regular Wronskian, so let's call it W for Wronskian, was what? The first row was 0. Cosine, which I defined as f1, and then sine, which I defined as f2. Now, notice here that Mathematica already has pre-built-in functions for all of the trig functions, right? So when I want to define cosine, you can just type in cosine. And notice that all functions that are predetermined, right, so all built-in functions are always started with a capital letter. Okay. So for example, if I wanted to write secant, I would start with capital S, E, And then I would get a set of options. Right? C, okay, I want secant. And if you actually call the name of a function, it's going to turn black. So see, when I just write SE, it's not black. Do a C, it's black. That means that it's a built-in function. So this would be the first row. Now, of the Wronskian, second row would be 0, negative. So now I'm going to use the original built-in functions, which are the same, right? So F1 or F2 is the same as sine. So this is the same as negative F2. And then cosine. And then finally, the last row for the Wronskian that we wrote down in the previous video was 1, negative cosine. I'm just going to write negative F1 and negative sine, so negative F2 of x. And then this is the matrix. Now, once you have each row, and again, each row is in brackets, in curly brackets, and each entry separated by comma, you want to enclose everything in curly brackets as well. So I should have done it that way instead of just putting the curly brackets in first, but I was just used to it. Okay. Now it's just the matrix. I'm going to suppress the output. So this one, so I do shift enter. That's what runs each line of code. You press shift enter, as we did in the other Mathematica file for Euler's method. And now Mathematica has recognized that W is this matrix. If you want to see it as a matrix, you can write the function matrix form, W. Here, I'm not going to put semicolon because I don't want to suppress the output. I actually want to see what it looks like. And that's our Wronskian. Now, we want to find the determinant, so let's do DET for determinant. And if you ever have a question about what a function is, you can just do a question mark at the start, then shift enter, and it'll tell you what it does. So let's delete this output. And here, let's do determinant of W, and we get this expression. And as you know, cosine squared plus sine squared equals 1. So really, the Wronskian in this case is just 1. Okay. Now, we had W sub 1, W sub 2, and W sub 3. Right? So I'm going to go ahead, and we already wrote them down in the previous video. I'm just going to go ahead and write them down here as matrices. So W1 equals, so do each row. Right? So row 1 was 0. And you can copy, right? Because actually this first row is the same row as above. Okay, so I'm just going to copy paste. The second row is the second row as from the usual Wronskian, and separate each row by commas. The last row is the one that changes. Now it's the last entry of the first column is g of x, which in our case is tangent, or F3. And again, you already have these Wronskians, right? So all of these determinants in your notes. Right? So you can just look back in the videos to see what they were. And then negative cosine, so negative F1. And then negative F2. And encompass or put curly brackets around all of the rows. Right? I'm going to suppress the output, shift enter. And if I want to check that I wrote everything correct, I can do matrix form, W1. And that looks correct. The only column that should have changed with respect to the Wronskian is the first column. Okay, that's why it's W1. Okay, let's find the determinant of W1. Cosine x, sine x was sine squared, tangent x. Okay. Now, we have two more Wronskians. So I'm just going to write them down again. Most of the columns are the same, so I'm just going to copy the original Wronskian. And this time, the column that's changing is the second column. Right, so it changes to 0, 0, and then the last entry is g of x, which in our case is tangent. So it's W2. Then I'm going to do W3 as well. Where did I go? Yep, so I'm going to do W3 as well. So here, what's changing is the last column becomes 0, 0, and then tangent, right, or g of x, which in our case is tangent. Now I need to find each of these determinants. W2, 0. Okay, I believe that's possible. Determinant W3, 0. Okay, so the reason why there's 0 is because of the algorithm for determining the Wronskian or the determinant of the 3 by 3 matrix. So what they do is that they do an expansion about a certain column. It's something that you'll learn if you want. Again, you can Google it if you want, or if you take linear algebra, you're going to learn how to do this. But basically, the determinant or the Wronskian of W2, right? W2 is 0, W3 is 0, right? And again, I did all of this in mathematics, right? So keep this or remember this. I'll post this, just this as a, I don't know if I'll post it as code. What I'll probably do for the homework is give you pre-built in code, and then you just have probably to change the functions or something like that. And then you just have to run things, right? So, but I'll include screenshots of this for the notes. Okay. So now we have all of the Wronskians. We're going to go back to our paperwork and find out what each of the u's of i's are.